Today, I'm going to be talking about the benefits of liquefied natural gas, LNG, over liquid distillate or diesel fuel as a secondary backup fuel for a peaking simple cycle power plant. First of all, what is LNG? LNG is natural gas, just like so many of you in the audience use to heat your homes with every winter. According to energy.gov, that natural gas becomes a colorless, odorless liquid when cooled to minus 259 degrees Fahrenheit. Natural gas itself contains mostly methane with small parts of hydrocarbons, water, carbon dioxide, oxygen, nitrogen, and some sulfur compounds. Each of these liquefy at a different temperature and thus are removed during the liquefaction process. And what you end up with is basically methane. So, why would we want to use LNG versus the standard liquid diesel fuel as a backup fuel? And the answer to that is reliability. Diesel fuel isn't reliable. It has issues with reliability because as a backup fuel, it's not used very often. The liquid diesel lays in the lines and basically turns to sludge. And then when the unit is called for on the secondary fuel, then the unit is not available and oftentimes won't go online. And that's important because one of our main features as a peaking power plant is we need to be there and reliable when our customers call on us to be there. This isn't an issue with LNG because the unit runs on a normal basis on natural gas. And so when called for, it'll run on regasified LNG. So what about the storage of LNG versus diesel fuel? The storage is basically the same. It's stored in a tank, much the same way as diesel. The tank for LNG has to be slightly larger and it has to be insulated to keep it at the minus 259 degrees. So there is an additional cost at the beginning during construction of the tanks. But that cost is more than offset by the additional tanks that would have to be built for the diesel fuel for deionized water that is used for control emissions, and all the combustion hardware that has to be changed, lines that have to be added, and pumps that have to be added. There's lots of changes that have to be made to add the diesel fuel onto the existing simple cycle plant. The third thing is the state permit that has to be permitted for the liquid diesel fuel that would not have to be done for LNG. The permitting process can be long, costly, and can impact how the plant can be run depending on what the state comes back with on the permit. Environmentally speaking, LNG is again the fuel of choice. There is no issue with an LNG spill. A spill of LNG quickly evaporates and leaves no residue behind. So I'm sure that probably brings up a question of safety. Um, LNG as a liquid will not burn, and as a gas, because it rapidly gasifies with any kind of temperature, has a very narrow explosive range. It'll only burn in 5 to 15% dilution in air. So what does that mean? That means if you have a spill of LNG, then there will be some gas released that will move quickly up and away from the side of the spill, and the area where the gas could ignite would be up and far away from the location of the spill, and then the gas would rapidly dissipate into the air with nothing left. That's not the case with diesel fuel. Diesel fuel is all about a containment that has to be built to contain the spill because it's not going to go anywhere. It leaves residue. It can be very messy and can be very expensive to clean up. The next thing I'd like to talk about is fuel flexibility. LNG again is natural gas, and so if you're running on natural gas and the need arises to switch to the secondary fuel, which would be LNG, then there is no issue to switch into the LNG because LNG would be supplied at pipeline quality, 850 psi, just like natural gas is supplied to the plant already. The problem with diesel fuel is, again, it's not reliable. If the system hasn't been maintained, then you've got that issue. If the system is maintained and the unit is running on natural gas, then there is the issue of fuel leaks that you cannot troubleshoot prior to starting the unit on diesel. When the unit starts on diesel fuel, the diesel is supplied at 800 psig, and the casing of the unit runs around 600 degrees Fahrenheit. Can anybody tell me what happens when you spray 800 psig diesel fuel on a 600 degree metal part? Boom. That's right. You're going to have a huge explosion, equipment damage. The unit's going to come offline, be unavailable, and could cost millions of dollars in damage to the unit. So even though that's not a direct cost of the diesel fuel, it's definitely a consideration to take into account. I think what I've shown here today is that LNG is the fuel of choice for a secondary fuel for a peaking simple cycle plant. Thank you.